Thank you for joining me. I'll be talking about using Scala in a Go first company today. We'll be using a bunch of Go, so that'll be fun. I'll jump right into it. We'll have ground to cover. I'll be talking about myself and ngrok, where I work for just a little bit. I'll give some context about data engineering, and then hopefully we'll spend most of the time on talking about Scala and Go, and what we do with Scala, what we use Scala, and what we don't use Go for this. All right, about myself real quick. My title is Staff Data Infrastructure Engineer at ngrok. I'll tell you what ngrok does in just a minute. I basically run our data platform. That's all you need to know. I'm from Canton, Georgia, about an hour north of Atlanta. I grew up in Germany about 500 miles north of here, so it's kind of fun to be back in Europe for a week. I used to be at Shopify and Deloitte before, spent a lot of time consulting, so a bunch of different data projects, and have been doing data engineering for basically my entire career. So that's my background. I'm not a Scala expert. I love the language. I love to be here. I love to hear all the talks about it. I'm not an expert. Like I've used it for Spark, and then I've gotten into Cats Effect and all that stuff. But I use as much Go and Python as I do Scala. And I have a cool blog you should read. It's hollinger.com. I write about Scala amongst other things, so check that out. About ngrok, we are a networking startup. We basically do networking for your applications. You might know our agent, where you can type ngrok HTTP, and like your local app is already on the internet like magic. Nowadays, we also do a lot of other production-ready stuff, right? We do auth, security, load balancing, DDoS protection. We have traffic policies where you can kind of route your traffic dynamically with like cell expressions. We have something like metadata about IP address that gives like geodata, and like if it's a fraudulent IP and stuff like that, that can like allows you to block like fraudulent actors with like one line of cell expression. That's pretty cool. I'm biased. I worked in that system. And we have about 70 people all over the States, and our engineering team is about 30 people. And we use Go microservices with about 1 million lines of Go. And we have a bunch of Kubernetes, protobuf, gRPC, Kafka. You can check us out at ngrok.com. Now, why I'm telling you all this, we did not have any Scala until about 1.5 years ago. And that recently changed. The reason why that changed is our data platform, which I am responsible for. We have a lot of data for a company that size, and one full-time data employee. You're looking at him. And we use it for support, analytics, go-to-market, and figuring out what product features to build. I hate the term like data-driven decision-making, but that's what we're trying to do. And our goal is basically for this project is to move streaming data about networks connections from Apache Kafka to Apache Iceberg, which is like an open data format that's sort of somewhat transactional. It's pretty cool, but it's out of scope for this talk. This is our architecture, also out of scope for this talk. It's sort of lambda-shaped, so it's kind of maybe interesting to know for context here what we're doing. So it's all streaming data. We're doing this with Apache Flink, in case you're not familiar. It's a distributed processing engine and framework for streaming data. We keep about 150 terabyte at rest, and we peak at about 20,000 events a second. This is metadata, traffic data, which we redact for privacy reasons, of course. Routing and internal events. If you listen to one of the Netflix talks, we talked about like how we capture events. We do something similar. We get like events about like product usage and stuff like that. So it's a lot of different events. I think it's like 70-ish like schemas or so. It's not quite like big tech scale, but it's pretty sizable for a company of our size. Like I said, it's all protobuf via Kafka. And the important thing is our engineers can change these Kafka schemas, right? These protobuf schemas. Because when I joined, I wanted to make sure that that the data stuff is not like in a silo, right? I wanted to make sure we're part of the engineering organization, and I didn't want to be outside the engineering organization, and I also didn't want to force people to write data code if they wanted to work on the ngrok product, right? And so this is why Go engineers can change a schema, and that basically generates Scala code. And some of these schemas are enormous, since a lot of them are denormalized, because keep in mind they're designed for gRPC communication between services, not necessarily to write stuff into a database, is what we're doing with it. Some more context, like I said, a small team, we have to rely on generic pipelines and automation, because I can't write like separate jobs for 70 different schemas. That's just not reasonable. We have a lot of diverse data, right? It's not just your standard data engineering. I copy over your accounts database and I join it with your sales database kind of in every question. It's a lot more complicated than that. Like I said, it's designed for gRPC, not necessarily for data engineering. And yeah, we have 3 jobs. They're all named after Lord of the Rings rivers, which wasn't the best decision, but it's fun to look at. All of the code is really in a shared Scala module, right? So we have like these jobs, but they don't do a lot by themselves. They just really, because they're so generic, they're all just basically implementing these generic interfaces we have in the shared Scala module. We also self-host all of our infrastructure, almost all of it. It's all on Kubernetes because as a networking company, that sort of makes sense to self-host a bunch of this stuff. And that's also worth mentioning because other companies that are bigger have teams to just run Flink or Kafka, for instance, right? So that's all context, just to say that we're using Scala for it. Now, why would that be? Well, I hopefully don't have to convince you that Scala is a great language, right? But the fact of the matter is that the lingua franca, the de facto standard at ngrok is Go, and in data engineering at large is Python, right? That has changed over the years, but nowadays Python is really the language that's used in data engineering in general. And at ngrok, it's almost exclusively Go. We do some TypeScript and such, but it's largely Go. But like I said, to achieve this small, we need to rely on automation and generic reusable code. And data engineering as a general discipline tries to make diverse, high volume, high cardinality data available in a usable format. You can call it plumbing, that's fine, because that's what it is. It makes data available for people to use and build pipelines in plumbing. And it's all about type safety and transformations and correctness. And half of all data code is basically doing map and flat map in perpetuity. If you think about it, you have data coming in, you want a different format. That's really kind of what it boils down to. It's also very important to make sure that type A is actually type A. If you use Python, you don't really have that guarantee, right? And I hope we can all agree that null is not the same as an empty string or as the number 0, and we'll get to why that is important in a minute. And I always like to say bad data engineering code is a bunch of scripts, and good engineering code is software. And for me, that's a huge distinction. But remember, a language is just a tool. I will talk about Go a lot. I will talk about Python a bunch. I like them both. I love Scala too. But ultimately, we're trying to achieve an end goal, and language is a tool for it. So I think that's worth calling out. Now, why Scala? Scala has a lot of useful features for this problem space, right? The type system is the superpower. Building primitives for something like an option, that is not a given necessarily in a language like Go. Type classes for flexible, reusable code that can handle various shapes of data and various types. Lots of abstraction methods, very expressive transformations. We have the entire JVM ecosystem available, which is not true in Go. It's very much true in Python. It's not true in Go. And we have a compile support to ensure correctness and type safety. Small team, complicated data. I keep repeating this. And so generic code and good abstractions are paramount. Now, how to actually do it. This was just context, 7 minutes of context. The most important thing is write idiomatic but familiar code that adds something, right? So you don't want to write Scala that looks like Go. You want to write Scala that's approachable and add something useful for the problem space. Basically, you want to solve frustrations, right? If you have a data engineering, they're using Python or Go, they might have frustrations with those languages. And introducing Scala helps me to avoid some of these frustrations and solve them. Type safety ambiguity is one example. Writing actually generic code is one example. And making abstractions easier is another big thing. We'll go through all of them in a little bit more detail. And we want to make it approachable, right? We want to use familiar features, but we want to still be idiomatic. We just don't want to write Scala that looks like Go or vice versa. Now, here's a list of what to do. This is not an exclusive list. There's more you can do. There's less you can do. Those are just some cherry-pick things that I think are worth talking about. So let's jump right into it. So this one is obvious. A lot of these are obvious. I will say that in advance, but I think they're worth calling. It's kind of like Sun Tzu, Art of War. Somebody had to say it. Here I am. Use case classes to accurately model your data, right? Case classes as an immutable way of modeling your data are a core of data engineering in general. You can write these by hand, or you can use Scala PB for protobuf, for instance, to generate them. You can use other ways of code gen, of course. We do both. They both have pros and cons, basically. The important thing is that you use correct types for whatever that is you're doing. And you should not be afraid to use new types or find types or aliases to be as expressive and as correct as possible. So what I mean by that is the compiler is your friend, use it. So if you have a method that your compiler can help you achieve, or like a system your compiler can help you achieve, use it. So here's an example, right? An ngrok ID is a string. That is true on paper, but actually it is a case to it. That's a case sortable unique identifier. They kind of look like this. I think it comes from Google. I'm not entirely sure. But they're kind of cool. They have this kind of optional prefix here. They're sortable, they're unique, they're kind of like UIDs on steroids. They're pretty neat, but they're not strings, right? They are case widths. Now you could be using a case width as like a case class, as like a new type, or like a fully qualified import from some case width module. You could also do what I did here and just put in a type alias to say, hey, okay, this is going to be an anchor ID that has to be a string. I could also use a refined type, right? I could say, in order for it to be a case width, it actually needs to be parsed as a case width, right? There's a bunch of different ways of doing it. I'm using alias here because it's easiest to put on slides, frankly. But it is something I do relatively frequently if I just want to tell people, hey, this is a case width, this is not a string. But refined types is something I really love. They're really great for this. And it looks like this, right? In your product, in your table row schema here, for instance, that's just modeling a data table row. I'm saying event ID is an ngrok ID. It is not a string, right? That's a huge distinction, and just being very explicit about it helps a lot. And we do something similar in Go, right? In Go, we just have this type ID of struct, which is basically just a little struct that holds onto a string that is an ID, and there's an extension method on it that lets you like validate it, for instance. But it's very something familiar that we do in Go too. Scala is just more ways of doing it. Again, refined types are one of those examples. Advertising mutation. Now, mutation in real life code is sometimes necessary. That's just a cold hard fact. If it's happening in Go, it's obvious. That's a nice thing about Go. In Go, it's a pointer. It looks like this, right? You have to do something, an object, struct thing, and struct thing is a pointer. So if I see this signature, I know it's going to mutate the object, right? Because it's a pointer, it doesn't return anything. It's reasonable to assume that that's what's happening, and the method name is horrible, the function name is horrible. With Scala or Java, that's not always obvious, right? It's essentially a kind of hidden side effect. So what I did, I redefined ref from cat's effect. You might be wondering why I'm not pulling in cat's effect. I'll get to that. But I basically have this in my code base here, and it just says ref of a equals a. That is simply a hint. It's a hint for humans, not for the compiler, to tell you, hey, this is a reference that's going to be mutated. Why is that relevant? Well, since we're using Flink, sometimes it's necessary to do that, right? So here we have the stream execution environment, which is basically the Flink execution environment that builds out kind of the DAG. That gets mutated because it's a Java thing that's kind of leaky. And that's we're using the ref method here to tell us, or not the method, the ref alias to tell us, hey, we're going to modify this thing even though we're not supposed to, but it's sort of hard to avoid here. Yeah, it does nothing by itself, but it just makes it obvious that this is happening here. I also sometimes use annotations, but that's kind of like very Java stylistic. It's more useful if you're in a Java shop or in a Python shop, like an annotation might be a useful method. Similar kind of vibe, just like make sure that someone who might not be familiar with the languages knows what's happening, basically. Except that null is real. This is another thing that is a harsh reality, right? Like in Scala land or in functional programming land, we tend to pretend that that doesn't exist. I used to work on a code base that had like a Scala fix rule that says, hey, don't use null, which I understand, it makes sense. It's just not necessarily realistic. We want to avoid situations like this. So this is going to be a little bit more Go code. In Go, and this is something important to know, strings are never null. Strings are either set or they're an empty string. Now, you could argue that that is correct, that a null string doesn't make sense. I would argue against it because it does make sense because we use a string, say in a database schema, they very much can be null. There's a whole discussion about this online, why that is, but the reality is a string in Go is either null or set, is either empty or set. It's never going to be null. So in Go, you do something like this, right? You have a reserved domain, it has a CNAME on it. Now, CNAME is a DNS construct. An empty CNAME is not valid. It's an alias for domain, right? An empty CNAME is not valid. It does not make any sense. It's simply not valid as a DNS entry. A null CNAME, that would make sense, right? If it's unset, that means you don't have an alias for this DNS entry. So the following expression here, CNAME equals empty string, is basically just invalid. It doesn't make any sense. Now, in Go, what I have to do, I have to use a pointer to a string. And a pointer to a string would allow me to actually set a nil value to it, and I could actually check for it. Now, additional complication, Go also has typed nils, which is another wholly fun thing to deal with. But essentially, you have to be working with pointers to strings, which is super awkward in Go because Go has a tendency to be very boilerplatey with stuff like this. So you need a bunch of helper methods or convert back from your string, from your pointer of string back to a string, which you can't do if it's nil. So there's a whole sort of rabbit hole here on how to deal with nils in Go. Most commonly, you see these sort of extension types like SQL.nullString, which again, your standard methods that work on a string are not going to work with it. Option types can be a thing in Go. There's libraries for it, but it's not a thing by default. Now, in Scala, the way I approach it is, again, relatively obvious, right? I try to use an option where I can. This is a different example, but it's the same example as from before. Here we have a service, and it's an option of string, right? We use this built-in primitive in Scala, which is an option of string. It doesn't have to be a literal null, but it accurately models the reality that this string can be null, and it makes sense. The service here can be null, as opposed to the Angkor ID, which cannot be null, right? So we're using an option to be just very explicit about it. And I think this is one of those things that really adds something to our code base, and this is why Scala is a good choice here, because it has these kind of things integrated. So do other languages, in all fairness. But again, it's just an obvious thing that really tells me, hey, this can be null. Now, in addition to that, because we're having to be pragmatic with this kind of code, sometimes it needs to be literally null, right? So I can go from option to a literal null. In this case, I have to deal with Avro, which is a Java library, right? And so in this case, I got to say, hey, I need an actual null, so I get the null out of it. And my Scala fix rule wouldn't help me here because I need a literal null. And sometimes it's even more extreme, right? Sometimes I'm calling basically Java code directly, and I'm throwing in a direct null here because that is the default value of this Avro field, right? All that to say is null is not great. It's impure. It's it's lying at us. I get all the arguments, but it exists in my database, so I have to model it accurately. Use compiler macros on CodeGen to your advantage. This is a bit of a controversial point. I said earlier that you can hand roll your models, you can CodeGen stuff. The use case that we have for is we basically have events that have like 50, I think it's actually 55 distinct shapes, and we didn't want to model them by hand, especially since, keep in mind, developers can change them, and if I model them by hand, I'm forcing them to write Scala code, and they might not want to do that. So we basically auto-generated all the Avro schemas for all of these models, and this saved us a lot of time. And by enabling people to not touching Scala code and still writing Scala code, I can basically make the transition a lot easier for people to do their day job and still add something of value to the data platform in this case by using Scala sort of hidden in the background. But it has complexity cost. We put together this thing here. I'm not going to go through it. I also cut off half the stuff so this code itself doesn't actually make that much sense. But it's got pretty complicated pretty quickly because we had to deal with all these different distinct schemas. In addition to that, the schemas themselves were hidden in an envelope schema we had to extract. It's very complicated code, so part of me does prefer something very simple like this, which is, again, our product table from earlier, which is just hand-rolling models by simply redefining case classes for everything you do in data engineering. Now, I don't necessarily think that there's a right or wrong to it, to doing it like this, where I have an apply that creates the model, and then something like as row data that gives me back an Avro row data. It all kind of depends on your use case. We've done both. We are doing both. Some of our jobs are hand-rolled. Some of our jobs are auto-generated. If I had to sum it up, I'd say something like, if you have full control over your model, right? If you have a database schema that you completely own, you hand-roll the models because it just makes your Scala code easier, which is ultimately what you want to do. Less code is best code in this case. If you need to scale you as a human being because you can't necessarily write code for a whole team, then CodeGen is a powerful tool. Just keep in mind your code is going to be complicated, and it's basically tech debt the second it kind of hits main. Yeah, we also use a lot of CodeGen and Go, so this made this a little bit easier for us. We do CodeGen a lot of our code, not just protobuf, also various other things. So that makes it a little bit easier. Brownie points if you know where this is from. High order is best order. So this is a very common pattern in Go. So we basically just have a high order function where we pass a function to a function, right? Super simple, very idiomatic in Go. It's something that a Go developer is going to be very familiar with. Another thing that's very common in Go is something called functional options. They're really cool. They look kind of well for a Scala developer maybe, but they're basically allowing us to define a type here that is a function, right? And then we can define a function that returns a function that mutates a struct, which is not very Scala-like, but it allows me to do something like this, where I create a thing, in this case like a struct, and I can give it something like with refresh after, which is basically just options on top of my struct. In this case, for instance, I can create a cache, the cache needs metrics and options, and in this case, this cache is going to expire after 30 minutes. That's all done with basically passing functions around. So doing something with higher order functions is something that's going to be very familiar to someone who's very used to Go, right? Anyone know where this is from? No? H1_4? Well.
Could you explain?
Sorry?
Could you explain what it means on the right side?
Yeah, it's H1_4. It's like a 4X strategy fantasy game. It's great. They don't pay me to say it, but it's fun. And that's the order campaign or whatever. So, all right, higher order is cool. So this is not going to look weird or smell weird, right? So this is Scala code again. This is all real Scala code. It's not like pretty just made for the presentation. This is actually code I took from our code base, right? So we have something that is a writer builder that builds a pipeline for us. We get this ref thing again that we talked about earlier, which is just data stream. And then we have this converter method that, a function that turns type B into row data, right? And we're just passing a function around. And the details don't really matter, but it's like this, Go developers going to look at this and they're not going to be like, oh, this is weird. If you explain the ref thing, they'll see, okay, this mutates a reference. These are converted, they see a function, it's like, okay, that's going to intuitively make sense. This is also not going to look weird, right? If something that just measures execution time on a function, right? This is going to be something that's going to look almost identical in Go, at least context-wise. Even the clock thing, we'll get to that. And I also have a spicy take on top of it. If you're familiar with Go, this might resonate with you. If you're not, it might not. In Go, you almost need higher order functions to do advanced composition because Go does not have inheritance. Go has something called interface of struct embedding, where you can define different structs or interfaces, just like C, that compose together, which is fun. But that has a lot of code overhead to do so. So oftentimes you need to do something like this, where you have a struct, and the struct holds onto a function. And in order to test something, for instance, I have to overwrite the function that sits on top of the struct as a higher order function. It's not entirely true that they have to do that, but it's a pattern I see a lot. So my spicy take is that you need higher order functions at a certain point in Go, versus in Scala, you need them indirectly, of course, with map and flat map and things of that nature. But in Go, they're sort of forced upon you at a certain point. All right. Speaking of composition, so Go's interface composition is rather basic, limited, very verbose. Makes things easy to read, but hard to reason about once it gets a little bit complex. And it's one of the few things I actually dislike about Go. I said earlier, I'm relatively agnostic to it. I think every language sort of serves its individual purpose, right? But it's one of the few things that I find truly annoying about the language, because it makes it so that making advanced composition involves a lot of code. Now, I'll show you an example. In Go, we have something like an interface, right? It kind of looks like this. It is just a regular Scala trait or Java interface that defines the shape and the methods need to exist on a certain struct. But it's just method, it has no state, and has no properties. I can combine multiple interfaces by something called interface embedding, right? I can say this metering reconciler needs to contain a reconciler, basically, and those can also be struct, and structs can hold on to state too. And so I can do something like this, right? I can have a reconciler service that does real code, and this struct here makes it an actual reconciler. Like this reconciler service is a reconciler, right? It fills that type definition, and the mock reconciler service that is used for testing is also a reconciler, right? And so those are both correctly implementing that interface, and this is how I sort of compose programs in Go. We don't have in Go's inheritance, right? We don't have any way of inheriting stuff. By having interface and struct embedding, we sort of have mix-ins, kind of, sort of. It's debatable, I'd say. But sort of that's where it ends. There's other ways of composing stuff, but basically that's what you do. Now, in Go, we compose entire programs from services, right? So, and we also can use generics to do so, but those are relatively new. I've had multiple people telling me over the conference that they didn't know that Go had generics. Yeah, that happened in 2022. They're all invariant. They're, again, relatively basic. But they basically, I would take this example from earlier and make it just a little bit more generic, right? I can have an interface that has generics on top of it. I can do something like this, where I do this interface of struct embedding with generic interfaces or structs. So I can be a little bit clever about it, but that's sort of where it ends in terms of composition in Go. Now, in Scala, of course, we can make stuff actually truly generic, right? So we want to make use of language features that are available, right? If they're similar enough, just a little bit more powerful. So we can take advantage of inheritance and generics, right? Like Scala gives us the option to use OOP if we find that is a reasonable choice. And I try to be a pragmatic person. I think sometimes OOP is a more reasonable choice than being pure functional, especially if you're trying to do something that is, again, approachable for someone who might know Go, maybe they know Java, maybe they don't know Python. Certainly the case for us, a lot of our developers know Java from previous jobs, for instance. And real code might look like this. And again, this is copied from our code base. This is not designed for this talk, right? So it's not super pretty, but it's realistic. So we can use something like type bounds in this case, and when it's one of our jobs. We can have a bunch of different arguments. Some of them might just be a case class that's sort of static, that is like a configuration file. Others might be generic services like this consumer builder. You might see this code smell here, right, where like input equals output. It just happens to be for this service the input type, same as the output type for this consumer. Should this be refactored? Maybe, but again, it's realistic code, right? We built this builder once. We're using it here, and it's not the perfect fit, but it's also not worth building a whole new builder that just consumes from a data stream, right? And then we are also using the clock thing. I'll get to this, I promise. We're also extending, right? It's this pragmatic OOP where we extend a class to share some behavior. We don't share state, but at least behavior. So you might have a trait sitting on top of it, right, where we have the build method, and I even implement stuff in traits, right? You could argue that you shouldn't be doing that too. Again, being very pragmatic, right? If someone looks at this and they know Go and they understand inheritance, and they'll be like, oh, okay, this inherits from here, this implements it here, makes sense, works for me. So a lot of this is just being pragmatic about it, and then this is how kind of real code looks like. This is another obvious one, but this is very much worth calling out. Please write tests, especially for data engineering. Like it's so common not to see test cases in like data engineering code bases. And to make this a little bit more obvious than just say write tests, write data-driven tests. So when you're generating code, it's okay to test library code, is basically what I'm saying. So in this case, for instance, here we're using Avro schemas to generate database shapes, essentially, right? And I have a few test cases that are actually just Avro schemas, and I know how they're supposed to look like. And I just assert here, hey, this derived schema is supposed to look like this as a literal string. It's tested as a string, so the output of SPT or of Scala test rather is going to be like, hey, those two don't match, right? They look weird. And as a human, I can see, okay, those two JSONs don't look the same. What's also a good idea in general is to test all possible permutations, even if the tests themselves are basic. Like usually if you see a test that is just pass or fail, probably not a good idea, but we do this, and again, this is taken from our real code base. I simply try to encode every event that we have, but I don't check the output. I just see, does it encode, does it fail, does it crash, does it do anything weird? And I do this because, keep in mind, our Go developers basically generate Scala code, right? I do something clever with it, and I add like metadata on top of it. But I basically just have automated tests, and those run on CI that make sure that somebody changing Go code in a way that I didn't anticipate is not going to break my Scala build. So yeah, please test your code. And even do something that's unintuitive if you're really doing something that might break while you're not there. Say, for instance, you're in Europe and you're giving a talk and somebody is working in the Eastern time zone. They might break your Scala build. That could happen, right? But at least they wouldn't be merging something in the main that would break my database schema and cause like an actual incident, right? It'll be caught by test, caught by CI. And yeah, so that's a simple but effective technique. Yeah, you want to fail your test fast, basically, right? You want this stuff to fail. You want it to stop you from having bad code on main. This is my hot take for the day. So for those who are not aware, context.context is basically a way to carry cancellation signals, deadlines, and request scopes values across API boundaries and Go routines. Yes, I stole this. It's basically a way of saying, I have a context, the context has a lifetime, I can cancel my context, and this is going to do stuff like gracefully shutting down a program, draining a Kafka consumer, stuff like that. It's essentially a synchronization mechanism for Go programs. So essentially, if you see a function like this, connect with a context in it that just returns error, is functionally the same as this. Pick your type classes, whatever. But basically, a context in Go indicates there's going to be side effect, or multiple. I advise against effects in Scala in this use case. We'll get to this in just a second. But it's not an unknown concept, right? So if you talk about effects, even if you don't actually use an effect framework, it's going to be familiar if you like point people to say, hey, remember this context thing that we're doing? It's basically that. And it makes for fun bugs. This happened last week. I spent way too much time figuring out a context bug. They happen, right? It's complexity, it's side effects. Context help us to sort of understand that there are side effects. So we know what to look for, similar to effects, right? Effects protect us from side effects, but again, largely in theory. Similar to what to do, here's what to avoid. Again, it's a smaller list of things that I think are useful, but it's not a complete list by any means. Don't use effect systems. If you remember when you learned Scala for the first time, you saw this, and maybe saw this, and you saw this, and you saw this, and this is what it looks like. Some of it still looks like to me, there's this wonderful talk about HTTP4S that explains what a Kleisli is. I get it, right? I understand effects. I like him to, I have a side project called Bridge4, again, a reference for those of you who get it. It's a distributed system from scratch. I wrote it as a learning exercise. It's using, oh my. It's, yeah, it's using hard kind types, using effects, using cats. It's a very fun project to like play around with, but it is very confusing for people who are not necessarily functional programming experts. I don't want to explain what a monad is. Option of A doesn't count. Not saying the word monad helps a lot. It's not even a joke. It's option of A might be monadic, but like not saying the word monad doesn't scare people, basically. I also don't want to explain, but lock info is actually a side effect. Yeah, I get it. It could write to disk. It is a side effect, but I just want to throw a lock in somewhere. Or I can't just run get or run safe run sync. Yeah, I don't want code just to be approachable if people know functional programming, right? I think Martin said something to the effect of like I have to teach people Scala and then cat's effect. This sort of doubles the cognitive load, and I think that's very much true. Similar to that, this could have gone in the previous section. Type classes, yes, they are too powerful not to use, but they're a very unknown concept for people who don't know functional programming. It took me a long time to sort of wrap my head around them. And I often have to remind myself, like something that is intuitive for me now was not necessarily intuitive a few years ago, right? And it was very confusing. But it really does unleash a lot of potential that Scala has for truly generic reusable code. Here's again a real example. Like I said, we have to redact a bunch of data and then this and these data streams that we have because it's, you know, I don't want to store certain things and I'm not allowed to store certain things, right? We're GDPR compliant and all that stuff. So we have this redaction type class, and it does like this redaction. If this is real or not is a different question, but we do have redaction as a type class. We have implementations of it, and I can say something. Hey, this has to be redacted. My compiler is going to tell me if type A is not of type redaction. Basically, you're not allowed to build, right? And the compiler helps me to be compliant, and that's just a superpower I want to use, right? It's not too different from Go. Again, this is a little bit more Go code. Just if you use type class just for extension methods, you can kind of do something like this. But since we're in the end, this is the example for like, hey, I'm enforcing it, right? But since we're in the what not to do section, don't make your behavior entirely dependent on imports. I think this is general Scala advice, right? You want to keep your companion objects close. You don't want to make everything dependent on imports. Scala 3 made this a lot easier, of course, with a given syntax. But keep in mind that it's hard for people to track down where like an implicit value comes from, even for like very experienced Scala developers. For someone who doesn't even know implicits, they're gonna have a very hard time. I've had people tell me at work saying, oh, I like Scala conceptually, but implicits are hell. And I'm like, I get it. So I'm very explicit about them. I try to sort of compare them to Go, and this is finally this clock example that we have. Here's how the clock looks in Go. It's an interface. It looks kind of like this. It gives me the option to say, you know, time.now, and it makes it testable, right? I basically just have the same thing in Scala. It's just shaped slightly differently. So I have something like ngrok flink, blah, 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 system clock. That's a real clock. But I always say using tclock, and I don't do some like fancy import. And once I generate or actually create the actual annual object, I tend to explicitly pass the clock object. I am aware I don't have to do this. It just makes it so much easier for people to read and say, okay, here's this where the clock's coming from. It's not just in scope. I don't have to have a fancy IDE. Keep in mind, people might not have a Scala IDE available to just look at your code, right? I'm very explicit about my implicits, basically. This is one that I just have to admit where I made a mistake. I wanted to introduce a monocle and lenses, so I thought it would make our code easier. It didn't. It's a very cool concept, very cool library, but it really made our code too hard to work with. It was intuitive for me. I had a coworker of mine try to like change a schema, and they were not happy with it, and it was way too complicated. And I was like, oh wait, lenses are cool because you can change immutable data that's deeply nested, and like it's mutable because like I have to get this whole spiel about why this is cool. Again, it assumes that someone is familiar with functional programming. If they're not, it's just going to be random symbols, and it might work for you. It just didn't work for me, and this is why it's on here. I'm gonna skip all this code, but it's it was too much. Looking at the time. Excessive mutation is another thing. I said earlier, mutation is fine, it's realistic, but just because you can mutate stuff and like annotate it, just don't overdo it. In Go, this looks like this, right? We have something like an operation on the hot path. We sometimes have to modify something like HTTP start time, right? Like it doesn't make sense to set this value when you create an HTTP request. It has to actually start for this value to be set, right? If I set a time to an HTTP request that's being like passed through our system, I can't set the start time until I actually start processing the system, the request, right? It doesn't make sense. So for Go, this makes perfect sense to set something like a value on a struct at runtime, mutate state and combine state and functionality, in other words. But at least Go makes this obvious, right? It has this like pointer type that I mentioned earlier, and it's like this here be dragons thing, be careful, we're gonna mutate this most likely. Since Scala doesn't really have this, again, use your type hint, just don't use this as an excuse to write Java in Scala, basically, is what I'm trying to say. Auxiliary things, I have to rush a little bit because of the time. These are just as important as writing code. Enforce your stuff in CI, right? So one thing I really love are Git hooks. I think they're fantastic functionality. I updated this repository not too long ago, where you just run Scala format and Scala deploy on CI, right? I have it as a Git hook, and I enforce that people are doing it with CI. By having Git hooks, they don't have to think about it. We also like limit the scope of them, of course, so I don't have to do it every single time. And as a side note here, you can see our compile times. I've talked to a few people at this conference about compile times, and I'm going home with a lot of ideas. But yeah, long compile times can be frustrating too. But we can work around this by, for instance, only building if Scala code actually changed, obviously. I'm saying obviously, I'm not sure if it's how obvious it is, but there's also something to keep in mind. If you do this, keep your compile times in mind because it's going to be in people's faces a lot more. Use standard tooling and pick your battles. Now this is a funny one. We have a developer CLI. Here's a little article that a coworker of mine wrote, which came out last week, about a tool called ND. You can also Google ngrok ND, you'll find it. It's basically just a CLI that we use for all of our developer tooling. You can do like build Go code, well, not build Python code, but test Python code and do like ND Python test or do ND Go build. I have the same thing for Scala. I implement in the same code base. I want to make sure that I use the same tooling that all other developers use for Scala, and it's discoverable, right? I can type ND, autocomplete, and all Scala shows up just like Go shows up. That's been a pretty good technique, just be aware, hey, this is available. And also make it known you here, right? So this is an example from our protobuf stuff where this is a very specific thing I need to do for Scala where I need an option instead of an A. The details don't really matter, but I have this comment in here and I'm saying, hey, I exist, Scala code exists. You don't usually have to touch it, but in this case you might have to. Here's why. Yeah, sometimes a little comment goes a long way because, again, keep in mind people might not be aware of what Scala is and why using it for and why option of A is different than A. I also like to say use tools you can find docs for online. For instance, if you use SBT instead of Bazel, which is funny because I talk to a lot of people about Bazel. We might change it in the future, but I start with SBT because it's easy to Google, because it makes it just easier to maintain for a small team. And if you use something like Bazel, Gazelle, just be aware that it doesn't make it more approachable, but it might be worth the effort for building it out so your compile times are shorter. Just keep in mind that don't be clever with auxiliary tools too. Just try to use whatever is available and what people are going to be most familiar with and what people are going to be able to maintain. Now we have Bazel expertise in-house, so we might actually move to Bazel. It's just worth calling out in general that if I were to do this in a Scala shop, my decision tree would look different, probably. Build ops, you can call it DevOps, which makes you happy. Basically, I'm just saying build dashboards, integrate alerts, use monitoring tools, use standard metrics if we have them available. Again, pretty obvious stuff, but basically I want to make sure that my dashboards that use Scala for Scala programs look the same as all other services in the organization. I don't want to be the opt and out. I want to build the same, observability stuff as all my other services, basically. Makes it less scary and makes it actually maintainable. I'm running out of time, but would I do it again in future plans? Probably. I could spend a lot of time on this question. The important thing is choosing a language nobody else is using kind of smells like a vanity project, right? Like, why would you do that? I hope I was able to sort of get my message across where I think it's a good choice for this particular use case, this streaming use case, this generic use case, this high volume kind of use case. But it all very much depends, right? I'd choose Flink again, but only with a lot of lessons learned for Flink. That's another thing that sort of plays into this, of course. I generally use Scala again unless we work in the Python-only team because the overlap between Python and Scala is quite large, but it's all sort of very hidden away between a lot of things. Data classes, for instance, immutable data in Python might be familiar, but not necessarily. I can assume that versus in Go, I can say you know what a higher order function is if you write Go. It's very different sort of vibes. I still think Go is a great language for ngrok and auxiliary data things, just not necessarily for these generic Flink pipelines. And so we use Python for projects with less extreme correctness and speed and abstraction requirements, because I think it's just easier for people to get into. And keep in mind, hiring, it's something we're all aware of. It is easier to hire a Python developer than a Scala developer. That's just sort of a fact, and that's something we have to keep in mind when choosing a language for these kind of projects. And also, this is always relevant. This will always be true. All right, that's it. This QR code takes to my website. I have articles about Scala and about QGIS and about Python, and I write about stuff I find interesting. I'm not necessarily an expert in those, but I like to write about them, help me sort of understand stuff. This takes me to my GitHub, where you find all the code that I output. And yeah, if you have questions, I'm available.
Thanks for a very interesting talk. So question, or actually two, but they are connected. So what's the estimated buzz factor of this code? So is there anyone at the company that can jump in if you are out on a vacation? And how did you convince your boss to be able to write in Scala? Because that's a question many people always ask.
Yeah. These are both great questions. So yes, other people are able to maintain this code base because I spend a lot of time writing documentation. I didn't call that out specifically, but it's something I do. Let me answer your second question first, because I kind of answered the first one with it. We went through this RFC process when I architected the system, this whole streaming system, because it was net new. And I did this vendor assessment, this language assessment, saying, hey, can we do this in Go? The answer is not really, for various reasons. I had a whole slide about comparing the languages and why we chose Scala specifically. But I talked to the engineering work with it. I said, hey, listen, I think our options here are Python, Java, or Scala. My opinion is the following. I think Python is not great largely for the type things. That sort of static analysis is not the same as a compiler, safety aspect. And Java, for me, is too verbose, and I think we get a lot of benefits from Scala through the concise syntax, especially on the stream, because it's basically like FS2 kind of semantics, right, with Scala. But I talked to engineering, where I said, hey, listen, what do you think about this? I know some of you know Java. Do we want to do Java, or do we think we can get away with Scala, because I think it has benefits? And we sort of all agreed as a team that is fine. We approved this RFC, including my boss, and I basically made a case for the language, and I think I made one, not because I love Scala, which is part of it, I'm not gonna lie to you, right? But I think I had a good business case for it, and that's how we got it approved. And that's when we started building it, basically. But yeah, documentation for the first part helps a lot.
Just quickly, if you don't mind passing the mic around, because I think...
Just one quick question, maybe a bit generic one. Is there any feature from Go that you actually miss, or you would like to have something in Go to be one feature from Scala to Go to be implemented that you was affected the most
Yeah.
your work?
Less so with, like, okay, feature actually building just statically linked binaries in Go is awesome. More so general behavior of the language. Go builds are super fast, even without Bazel, which is pretty awesome. Scala builds with like CodeGen, especially once you get into like Magnolia, can be pretty slow. And vice versa, type classes I think are awesome. This is one of the few things that I'm really like, that's hard to replicate elsewhere. So I'd love to see that in Go or just better generics in Go in general because they're all, you know, kind of basic. But yeah, I think that would be it.
Hey, this was like a therapy session for me. I work in a Go company, and I maintain the only Scala project that we have there. So I cried a little bit, but not like as much as I expected. So my question is, so there's a thing like idiomatic Go, which basically people resist aggressively in adding features that do not feel Go-like, even though they're implemented using standard Go features. Because in our code base, like we added option because those zero values, they just kill me every single time. We have so many bugs because of them. Do you reckon the idiomatic Go kind of limits the possibility for cross-pollination between the team members that write Go and Scala? Because in our case, that's what happens. So like people will resist changes because we write Rust and Scala and other things, but they would resist any changes going back into Go, even though we can prove that here is a benefit. Like this will make it easier, especially the zero values for strings. It's just terrible, I think.
Yeah, I think this is a complicated question because if your Go code looks like the Go examples on the Go website, I think that's where Go is most powerful. Because do I love the fact that all return sets are tuples of values and errors? Not really. But the reality is like that's how Go code looks on the docs. That's how Go code looks in open source. This is how LLMs are going to generate Go code. So I think it's important to stick to the standards of the language because Go is such a relatively small language with an intentionally small scope. We do some of this extension stuff, right? We have like a syncx and mapx all for extension, right? Where like you have to do maybe like chunk a slice into like equally sized chunks or have like concurrency helpers and stuff like that. So we do that, but it all makes sense if you're familiar enough with Go. So we don't do anything crazy about it. And a part of that is to make sure our Go code stays Go code, basically. Personally, I have a bad habit of introducing Scala-isms into other languages, but I have to stop myself and have to recognize it because I think some of them make sense, but that's usually something I try to keep to side projects, and in a side project in Go, I would definitely use an option type too. Cool, well, thank you. Oh, is there more? Oh, sorry.
Thank you for your talk. It's a very nice experience. You share it with us. And my question would be, in one of your slides, you mentioned that not all, for example, changes in protobuf schema are in line with iceberg schema evolution. And do you perform any automated checks or tests as part of your pipeline to ensure that you are not merging some changes which can break in runtime upon this schema evolution? Yeah,
We
thank you.
do. Let me see if I can find this example. So what we basically do, I'm probably not going to be able to, sort of, ish, kind of, maybe. Yeah, sort of, yeah. So it's this type here. Oh, there's a cursor. I didn't know that. That's fun. Align schema is a type that is basically an Avro schema that is pre-validated and has metadata on top of it. That's the first step. So I make sure that I add my metadata onto those schemas because I need to know when you insert your record. I need to have like an event ID. I need to have this primary key situation sorted out. We do that. What we also do, and this is not really working all that well, it works for us, it's not a generic solution, is I have a service that is effectful that sets this align schema on startup time. So it'll start the Flink job, it'll talk to the Iceberg metastore, to Glue, and it'll tell me, hey, what's your schema? I look at the Afro schema, hey, what's your schema? I compare them and see, are you compatible? The answer is almost always yes, right? Because they're almost, protobuf and Iceberg are like nearly identical in terms of compatibility. There's certain things that just don't work. Example is I can't like add a non-option type to a schema because it needs to be optional in Avro to be optional in Iceberg, and I can't like add a field because what happens to the previous values kind of thing. That stuff we validate and we just basically crash. Like that's a catastrophic failure. Like if you manage to get that into the code base, it'll crash. And that's also what we test with with the unit test, but of course, the meta store itself is mocked, right? So that it only gets so far, but we test a bunch of permutations of what I think could happen. But this is why this is like an internal thing and not like a generic solution to the problem of schema evolution. But yeah. Thank you.